Okay, so let's talk about how we do integral defined functions. First off, you always look at the notation that is given to you. Sorry for the bell. Okay, so we're given to us that g equals the integral of f. So this is our area. Remember our acronym AX. So now g prime equals f, just the graph, and g double prime equals f prime, which is going to be the slope. So when it says find the following, g of negative 2, little g, we look up here, little g is for area. So we look here, the area from 0 to negative 2. So what's our area from 0 to negative 2? If we look, here's 0, we go to negative 2. If we found the area normally, it would be the area of these two triangles here. The area of this triangle is 0.5, the area of this triangle is 1. So the area from negative 2 to 0 would be 1 minus 0.5, which would be 0.5. But since it's negative, because we're going in the reverse direction, we have to change the sign. So it's negative 0.5. G of negative 1 is the area from 0 to negative 1. So let's look up here. The area from 0 to negative 1, here's 0, here's negative 1. It's just base times height divided by 2. So this is 1, but if we're going in the reverse direction, it's negative 1. G of 0. What's the area from 0 to 0? 0. That's called a 0 of the function. G of 2 is the area from 0 to 2. So if we count 0 to 2, so look at this triangle here. Base times height divided by 2 makes this triangle, 1. So 1, 2, 3, 4. So the area is 5. Area of 3, 0 to 3. So we have 5 plus, this is 3 times 2 divided by 2. 3 times 1 divided by 2 gives us 3 halves, or 1.5. So we had 5 plus 1.5 gives us 6.5. Then g of 4, we have to subtract this out. So 6.5 minus 0.5 equals 6. Now I'll find each of the following. G prime, we look up here, is the graph. So these are just the y values. So what's the y value of the function? At negative 1, it is 0. At 0, we have 2. At 2, we have 3. And at 4, we have negative 1. Write an equation for the tangent line. Okay, anytime you hear tangent line, 2 magic words, point and, slope. So point comes from at x equals 1. So 1, comma. Now to find the y value that goes with this, we always plug it into the function it's talking about. So g of 1. But we look up here, and g is our area function. So g of 1 is going to be the area from, in this case, from 0 to 1. So it's the area. And we look over here from 0 to 1, the area here, it's kind of tricky. This is 0.5. So the area of this would be 0.5 times 1 divided by 2, so it's 0.25. So it's 2.25. And then our slope is going to be g prime, because it's always the derivative at that point. But g prime is the same as f. It's the same as the graph. So it's the graph value. So if we look over 1, it's up at 2.5. So it's just y minus the y coordinate, which is 2.25, equals our slope, which is 2.5, times x minus the x coordinate, which is 1. Does g double prime exist? G double prime is the slope. If we look at 0, this is a sharp turn, so there's no way to draw the slope there. So we say no, because sharp turn. It's the same as asking does the derivative exist there. Will point of inflection exist at x equals 0? The answer is no, because we look at g double prime to see concavity, and that tells us about a point of inflection. A point of inflection is where concavity changes. G double prime is the slope. And if we notice, the slopes of all of these lines are positive, 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 positive. It doesn't change to be negative until we get to 2. So at 2, there's going to be a point of inflection. Not at 0. At 0, we're positive, we're still positive. So no, because concavity doesn't change. And let's move on. For what values of x in the open interval -2 to 4 is g increasing? Anytime you hear increasing or decreasing, you should think first derivative. So we look at g prime, because that's the first derivative here. G prime is equal to the graph, so it's the same as f. You want to know where is that positive. So in that case, it's above the x-axis, because we're talking about the graph itself. So where are we above the x-axis? Well, we're above the x-axis from -1 all the way to 3. Okay, where are we decreasing? So g prime, which again is f. Where is it negative? So that's where is it below. So that would be from -2 to -1 and 3 to 4. Concave up means f double, whoops, the page is what they're talking about. G, they're talking about g, so g double prime is positive. Well, g double prime is the same as f prime, so that's the same as the slope being positive. So where our slope's positive, that is our slopes are positive from all the way positive, positive, positive. They change to be negative at 3, so from -2 to 3. Oops, sorry. Then g double prime being negative would mean f prime is negative, so our slopes are negative, which indicates concave down. So that's from 3 to 4. Okay, max and min. Super important to look at the first derivative. So we're going to look at g prime, and this is going to be different because we have a closed interval test. So we're going to look from -2 to 4. Our possible max and mins happen wherever g prime is equal to 0. That's our critical numbers. So we look over here, g prime is equal to 0 at -1 and at 3, because g prime is the graph. So these are our two possible places. Let's look at the graph. What happens here? We go from negative to positive to negative. Oops. So let's mark those. Negative, positive, negative. So we have decreasing, increasing, decreasing. So this looks like a possible min, and this is a possible max. But we also have to test our endpoints, because this might be the max, see? Or this might be the min. We just don't know how high or how low it gets. So make a little chart. We're going to put them into the actual function we're texting. So plugging it into g, which is the area. And this is from part A. You can get these values. We're testing -2, 4, -1, and 3. These are our endpoints, and these are our critical numbers. So if you look on part A, -2 is equal to -0.5, and then -1 was equal to -1, 3 was equal to 6.5, and 4 to 6. So our max is at 3, 6.5, and our min is equal to -1, -1. Whichever one's the smallest, whichever one's the biggest. That tells you what your max and your min is. Alright, so here we have a rate problem. The big thing you need to know is when you integrate a rate, you get an amount. So it says, is the amount of pollutant increasing? Okay, increasing or decreasing, you should think about derivative. Well, the amount is going to be equal to the integral of this rate. So if we look at increasing or decreasing, we should be looking at the amount prime. Well, the derivative of the integral would just be looking at this function, looking at the rate. Is it increasing? We'll plug in 9, and when you plug in 9, you get a negative number, so it's decreasing because it's negative. Alright, now it's asking for how much. That's an amount. We want the amount, and it's after 30 days. So we're going to take the integral of this guy right here, the integral from u2 from 0 to 30 of 1 minus 3e to the negative 0.2 square roots of t dt. So you're going to go to your calculator. Sorry, I should have already had this pulled up. And we're going to push math 9, and then you type in 1 minus 3 second e, and then the negative 0.2 second square root x. Make sure you close both sets of parentheses, comma x, comma your rate is from your length is from 0 to 30. So we get, it takes a little while to think. Finally, we get negative 14.895. Where the units was gallons per day, and then times day, because that's 2 times, so it's gallons. But it wants to know how much is left after 30 days. To start off, there was 50. So we've lost, this represents the amount lost, so 50 minus 14.895 gives us 35.105 gallons. Alright, is the lake safe after 10 days? That means we need to take the integral of this function from 1 to 10, and from 0 to 10. So remember on your calculator, sorry, this is not acting too nice to me today. Push second and then entry solve. Change the 30 to a 10. Push enter. And we get negative 9.905. So we started with 50. If we take 50 minus this, we get 40.095, and that's greater than 40, and it says it has to have 40 gallons or less, so no, it's not safe. Okay, number 12. We have water being pumped out, and to figure out how much water does it hold 1 hour later, so we start with 1,000, and we're losing this amount of 5 minus 5e to the negative 0.12 t dt. So 1 hour later, this is measured in minutes, so we need 0 to 60. So put this in the calculator again, you get 1,000. We're just going to say our final answer. Our final answer is, for time's sake, 750. Oh, looking at the wrong thing. 741, and then 636 liters. Make sure you label right. Alright, soup is being cooled at this rate. So again, we know the temperature of time is 5, so we do negative 6e to the 0.1 t dt from 0 to 5. And when we do that, we get negative 23.608. Now some are confused, do we add or subtract? Well, the soup is being cooled, so we're going to do 97. You're adding this, but it's a negative number, so it's like you're subtracting. 73.392 degrees Celsius is the new temperature of the soup. Finally, motion. Motion, we're going to write down PVA. To get velocity, we take the antiderivative of the acceleration. So when we do that, we get add 1, so t squared divided by 3t squared minus 8t plus c. We want to figure out what c is equal to, so we use our initial conditions. Initial conditions are right here. So if we plug in 0, we get 3 times 0 squared minus 8 times 0 plus c equals negative 3, so c equals negative 3. So your velocity is 3t squared minus 8t minus 3. Alright, when it's a particle rest, set velocity equal to 0. So we have 3t and t. We have minus 3 and plus 1. So we get t equals negative 1/3 and 3, but we're going to throw this one out because time has to be greater than 0. So 0 and 3, if you plug in something in between here like 1, we get positive and negative, so negative and then positive. So we're moving to the left, wherever we're negative, which is 0 to 3. Moving to the right from 3 to infinity, because it's positive there. Alright, x of t. X of t is going to be taking the antiderivative of velocity. So we get t cubed minus 4t squared minus 3t plus c. We have to plug in 1, and we get 4 when we do that. So 1 minus 4 minus 3 plus c should be 4, and so we get negative 6 plus c equals 4, so c equals 10. So your position equation is all of this t cubed minus 4t squared minus 3t plus c, which is 10. Alright, finding total distance. You integrate the absolute value of velocity over this interval. Or you do your little t-chart with position. It's really important that this is position. And you would do the endpoints and then your critical number, which is 3. But in the calculator, you're going to write, I'll show you how to do this real fast. You type math 9, and then you can do number, or you can do second catalog to get absolute value. 3x squared minus 8x minus 3, close your parentheses, comma x, comma 0, comma 4, enter, we get 24. So that would be distance traveled, then it would give us units. And then displacement is the end minus the beginning, or you can integrate the velocity function, no absolute value signs. So if you do that, if I just integrate the velocity function again, but I take away the absolute value signs, didn't need to do that. So math 9, and then take 3x squared minus 8x minus 3, comma x, comma 0, comma 2 this time. We get negative 14, which is its displacement. But really we're going to say positive 14 because it's talking about just the number of spaces that's between the two. So that should be it. Hopefully you'll do wonderful. See you Monday.